Bioprinting, a promising solution to the organ shortage crisis, by Jacqueline Stewart. Organ shortages remain a serious public health crisis, with over 100,000 people in the United States waiting for transplants and thousands of dying each year before receiving a donor organ. The current transplant system cannot meet demand, which highlights the need for innovative medical solutions. Bioprinting offers a promising alternative by using 3D printing technology and patent-derived cells to create living tissues, potentially reducing rejection risks and shortening wait times. Although researchers have successfully printed skin, cartilage, and small tissue structures, technical barriers still prevent the widespread printing of fully functional organs. In addition, ethical concerns such as costs, access, inequality, and proper regulation must be carefully addressed. For these reasons, continued scientific research, clinical trials, and responsible government oversight are essential to ensure that bioprinting develops safely and effectively as a long-term solution to the organ shortage crisis. The development of 3D printing technology expanded rapidly in the early 2000s, originally focusing on manufacturing objects made from plastic and metal. Over time, scientists began adapting this technology for medical use, transitioning from printing non-living materials to printing biological materials made of living cells. This shift was supported by advances in regenerative medicine and tissue engineering, fields focused on repairing or replacing damaged tissue in the human body. As research progressed, scientists achieved early success in printing simple tissues such as skin and cartilage, demonstrating that bioprinting could function beyond theory. These early breakthroughs laid the scientific foundation for the continued development of more complex tissue and organ fabrication. Bioprinting is being developed because it has strong potential to reduce the ongoing organ shortage crisis. By using a patient's own cells to create living tissue, this technology may significantly lower the risk of organ rejection and improve transplant success rates. Traditional organ transplantation faces major limitations, including long waiting lists, donor shortages, and immune system complications. In contrast, current research shows real medical progress with successful printing of tissues and small organ structures, proving that bioprinting is more than just a theoretical concept. The growing scientific feasibility of this technology suggests it could eventually help solve the organ shortage crisis. However, continued research, clinical testing, and ethical oversight are essential to ensure it develops safely and responsibly. The organ shortage crisis is a major medical problem that requires innovative solutions because the current transplant system cannot meet the growing demand. There are over 100,000 patients on the U.S. transplant waiting list, and thousands die each year due to the lack of available donor organs. Even for those who receive transplants, long wait times and the risk of immune rejection remain a serious challenge. These limitations show that relying solely on traditional organ donation is not sustainable in the long term. As a result, new medical technologies such as bioprinting are being explored to help address the urgent and ongoing healthcare crisis. Bioprinting uses advanced 3D technology to create a living tissue by printing cells instead of plastic or metal materials. The process begins by harvesting stem cells, often from the patient, which are then mixed into a special material called bioink. This bioink contains living cells that can grow and develop into functional tissue. The bioprinter carefully deposits the bioink layer by layer, building the tissue structure according to the digital design. After printing, the tissue is placed in an incubator where it matures and develops under controlled conditions. This step allows the cells to grow, organize, and begin functioning more like natural human tissue. Researchers have already achieved important early success in bioprinting by creating simple but functional tissues. Scientists have successfully printed skin for wound healing and burn treatment, as well as cartilage used in reconstructive procedures. In addition, they have developed many organs known as organoids, which are small tissue models that mimic the structure and function of real organs for research and testing purposes. Bioprinting has also been used to create bone scaffolds that support new bone growth and repair. These accomplishments demonstrate that bioprinting is making real medical progress and moving closer to more complex organ fabrication. Overcoming the organ shortage crisis requires long-term, innovative solutions, and bioprinting presents a viable path forward. By creating personalized tissues using a patient's own cells, this technology has the potential to significantly reduce the risk of organ rejection while improving overall transplant success rates. Researchers have already demonstrated success in laboratory settings by printing skin, cartilage, and early form of organ structures. Continued advancements in stem cell research and patient-specific cell applications further strengthen the scientific foundation of bioprinting. Together, these developments suggest that while challenges remain, bioprinting could become a practical and effective solution to organ shortages in the future. Looking ahead, the future of bioprinting includes the potential to fully print functional organs such as hearts, kidneys, and livers, which can dramatically transform modern medicine. As this technology continues to integrate with stem cell research and personalized medicine, treatments may become more customized and effective for individual patients. If widely implemented, bioprinting could reshape transplant systems worldwide by reducing wait times and saving more lives. However, ongoing ethical debates and policy development will be necessary to address concerns about safety, fairness, and accessibility. Cost also remains a factor, as fully organ printing can average around $100,000, while smaller living tissues may cost closer to $1,000. Overall, with responsible advancement and oversight, bioprinting has the potential to revolutionize transplantation and redefine the future of healthcare.